Topic 2, Equation, Inequalities and Absolute Value. 2.4, Absolute Value, Lecture 4 of 4. In this section, our objective to solve absolute inequalities of the form as below. Second, absolute value ax plus bx less than absolute value cx plus dx. Number 3, absolute value ax plus b over cx plus d less than e, and absolute value ax squared plus bx plus c less than d. Also apply to inequalities involving notation less than equal, and more than equal. Now, let's discuss some example. Here we have one example for the both side modulus. For this form, we try to apply method squaring both sides. Inequalities of absolute value, both side modulus. Example 1. Solve the absolute x minus 3 more than equal to x plus 5. To solve these inequalities, firstly, we apply the squaring both sides. Next, we bring 2x plus 5 squared to the left hand side. Therefore, you can got x minus 3 squared minus 2x plus 5 squared more than equal 0. Remember this, if you want to solve these inequalities, so better we try using this factor. As we know, a squared minus b squared equal to a minus b, a plus b. Therefore, we can relate to these inequalities to this factor. X minus 3 as a 2x plus 5 as a b. Therefore, we can got two factor like a minus b, a plus b. Next, we can vector and got like this. This is a, and also this is a. This is b, and this is b. So we have two vectors, one plus, another one is minus. After that, we try to simplify in each factor. After simplify, you can got 3x plus 2 for the first factor, and the second factor you can got negative x minus 8 more than equal 0. So easy to simplify for these inequalities. Therefore, we try to factorize the negative x minus 8. So when we try to factorize, and then you bring the negative to the right hand side, so the factor will become like 3x plus 2 times 2x plus 8. But be careful about the sign of inequality. From more than equal is become less than equal. To solve these inequalities, because this is the quadratic inequalities, we apply the graphical method. As we know, this is the shape of the graphical method is a minimum, and we know that we need a less than equal 0. We need a negative part. So for the negative part is under the x-axis. So this is the answer actually. So finally, you can write down the interval notation. Close interval negative 8, negative 2 over 3, or we can write down in solution set. This is the final answer. We can got x, where x is more than equal negative 8, less than equal negative 2 over 3. Now, we go to the two example about one side modulus. For one side modulus, we apply method basic definition. Example 3. Solve the inequalities absolute 1 over x minus 2 less than 3. Because we have one side modulus, therefore we are using the basic definition. Before we want to continue to our solution, we try to understand for the basic definition. Absolute x when less than a we know that x is more than negative a and less than a. Or we can write down in this form: x less than a and x more than negative a. You must remember, when we have absolute value and the notation is less than or less than equal, so we must apply n. We must do n. And then after you write down the basic definition here, x less than a, and for the second part you must to switch the sign from the less than become more than, and from the positive value become to negative value. Using the basic definition, we can write down 1 over x minus 2 less than 3 more than negative 3, and from here we can write down 1 over x minus 2 less than 3 and 1 over x minus 2 more than negative 3. 1 over x minus 2 less than 3, we bring 3 to the left hand side, so become minus 3. We bring negative 3 to the left hand side, make sure the right hand side is 0. Next, we equalize the denominator, so you can got 1 minus 3 times x minus 2 divided by x minus 2 less than 0. And then you simplify until you got 7 minus 3x over x minus 2 less than 0. Now for the right hand side, same like the previous, we equalize the denominator, and after that we simplify. Lastly, you can got rational inequalities is 3x minus 5 over x minus 2 more than 0. To solve the both of rational inequalities here, we use table of sign. Firstly, write down x equal to 2, x equal to 7 over 3. This is the interval before 2, this is the interval 2 until 7 over 3, and this is the interval more than 7 over 3. Now, we write down the two factor here, 7 minus 3x and x minus 2, and this is our question. So firstly, we can substitute any value between 2 and 7 over 3. I choose 2.2 here. You can got substitute 2.2 to this factor, then you can got positive. Also for this one, 2.2, you got here is positive sign. Then for this interval, I choose 0. Then substitute to this interval, got plus, and also substitute 0 here, you got minus. Continue with the third interval here. You can substitute any value. Let's say I substitute 10. Here you can got negative here, and when substitute 10, you got positive here. Positive, negative, we got negative. Positive divided by positive is positive, and negative, positive is become a negative. So the final answer, we must relate to this rational inequality sign is less than, so we choose the negative sign. So the final answer for this part, open interval negative infinity 2 union to 7 over 3 infinity. Next we go to the second part. Draw a table. We know we have x equal to 2 and x equal to 5 over 3. Then write down the 3 interval here. Before 5 over 3, between 5 over 3 until 2, and more than 2. So write down we have two factor. First factor 3x minus 5, and the second factor x minus 2, and this is our question. So we can substitute for the interval less than 5 over 3. You can choose 0, put here, then you can got negative. And so when you substitute 0 minus 2, you got negative also. And for the interval 5.x to here, then you can got a positive. And then here you substitute 1.8 here, you can got negative.
Then for the last interval, more than 2, you can substitute, let's say 3, put here you can got positive sign, and put here you got also positive sign. Finally, we want to find out the answer. Positive is become a positive. Positive divided by negative is negative, and negative divide, you got a positive. So return back to this part is the inequality sign is more than, so we choose a positive sign. So the final answer for this one is open interval negative infinity until 5/3 union 2 until infinity. So what you want to do between two interval here, you must to do intersection. Next part, you want to write down the final answer, you must to do final solution. We do the number line. Okay, we have first interval here, must to intercept the second interval here. So draw a number line which is have three value here, 5/3, 2 and 7/3. Because open interval here, so you put empty circle on 2 and draw straight line to the left. Next, open interval on 7/3 and draw a straight line, go to the right. For the second interval, come from the green color here. So you put the empty circle on the 5/3 and draw a straight line, go to the left. And lastly, the interval 2 until infinity. So open interval on 2, go to the right. Section is the overlapping between first interval and the second interval. So this is the part. Okay, so the final answer you want to write down. The interval form is a open interval negative infinity 5/3 union to 7/3 infinity. Example 6. Solve the inequality. Question B. Absolute x squared minus 5x plus 3 less than equal 3. This is the quadratic inequalities for the absolute value. To solve these absolute quadratic inequalities, because we have only one side modulus, so we're using basic definition. Before that, we must recall about the basic definition. For the absolute less than a, x more than negative a less than a, or we can write down x less than a and must put word n because less than, then x more than negative a. Using the basic definition, we write down x squared minus 5x plus 3 less than equal 3, and x squared minus 5x plus 3 more than equal negative 3. To write down this definition, so be careful when the less than, we use n. How to write down? For the first part, you just copy the question without absolute value, and for the second part, you just switch the sign. Less than equal become a more than equal, and if here is a positive, so you switch to the negative 3. We simplify 3, bring to the left, then you can got x squared minus 5x less than equal 0. You factorize. For the second part, also we bring negative 3 to the left, and then you simplify, got quadratic, then you factorize. We got 2 factor here, x minus 2 and then x minus 3 more than equal 0. Because this is a quadratic inequalities, we apply method, graphical method. We have factor x time to x minus 5 less than equal 0, because this is a minimum, draw a minimum graph. And then we have intercept for 0 and 5, because we need a less than equal. So this is the part for the less than equal below x-axis. So the answer for this part is close interval 0, 5. For the second part, we have two factors, x minus 2 and x minus 3 more than equal 0. This is a graph minimum, so we have value 2 and 3, and then because the sign inequalities is more than, so the part is on the right and on the left side. The answer for this graph is half open negative infinity 2 union to half open 3 infinity. Okay, now what you want to do, for the final solution, we must draw a number line, which is do the intersection between first interval and the second interval. Draw a number line for the first close interval 0, 5. So put the dense circle on 0 until dense circle on 5. Then you try to join in between of them. I use the green color here. Then for the second interval, half open 2 until negative infinity, 3 until positive infinity. So because also 2 is a close, so you put here is full circle or dense circle, and the arrow is go to the left. For the value 3, also dense circle and draw a straight to the right hand side. So now you want to do the intersection between two intervals, the green and the red line here. So this is the part intersection. Okay, so for the final answer, if you want to write down in a solution set, x is more than equal 0, less than equal 2, or x is more than equal 3, less than equal 5. Or you can write down in interval form, close interval 0, 2, union to close interval 3, 5. Okay, that's all for today. Thank you.